Okay, so we're doing chapter 9, problem 61 here. So it says prove that in an elastic collision of two objects of equal mass, so m1 equals m2, which we can just call m here, the angle between the final velocities, so angle between v1 prime and v2 prime equals 90 degrees always. Okay. So let's go ahead and draw the situation here. So what this means is we have a mass m coming in at v1, hitting some other mass m here. And now we are, this gets collided out at some v1 prime. The other one gets come out here at some v2 prime. And let's call this theta and this phi. Okay. And we want to show basically that theta plus phi equals 90 degrees. So how do we show this? Well, let's start out by writing out momentum conservation. Well, that just tells us mv1 equals mv1 prime plus mv2 prime. Well, these m's can cancel out, and now we have a vector equation that v1 prime plus v2 prime equals v1. Well, v1 prime going off in this direction, v2 prime is going off that way, so we add these together by doing the tip to tail method. And now this must equal v1. Okay, well, what's the angle between v and v1, or v1 and v1 prime? Well, that's given as theta. What's the angle between v2 prime and v1? That was given as phi. Awesome. So we have this, and we'll label this third angle as alpha. We know that 180 degrees needs to equal theta plus phi plus alpha. So equivalently to proving this statement, which proves this statement, we could prove that alpha equals 90 degrees. Right? How do we know that? Well, because if we plug in this 90 degrees for here, that means alpha must be 90 degrees. So now this equation, we're trying to prove alpha equals 90 degrees. So since the collision is perfectly elastic, we can conserve energy, kinetic energy. So we have 1/2 m v1 squared equals 1/2 m v1 prime squared plus 1/2 m v2 prime squared. 1/2 m's cancel, which tells us v1 squared equals v1 prime squared plus v2 prime squared. Well, this looks like a Pythagorean equation. So if we have a triangle of lengths equal to these magnitudes, which, oh, we already drew that, we do have that, it must be a right triangle. So which one of these angles is our right angle? Well, it's telling us this is the hypotenuse. V1 is the hypotenuse. And for V1 to be the hypotenuse means the angle across from it must be the right angle. So the only way this can hold is if alpha equals 90 degrees. And looky there, that's exactly what we were trying to prove. So we know the angle between these two vectors is 90 degrees.